So this learning target is all about making the graph of polynomial functions, and in this case in this unit we're mostly going to focus on polynomials with degrees greater than 2. So we've already done linear functions and quadratic functions. This is cubic functions, which is power 3 and above. And then on that graph identifying all the important parts. So zeros, y-intercepts, local maxima and minima, and showing end behavior. So a zero or a root is something that you've heard of before. Just want to make sure we're really clear on the definition of this term. When we're speaking in terms of a graph, this is the x value or values. So we're going to write x value or values when y equals 0. And on the graph, those would be x-intercepts. And then y-intercept, this would be the y value, and sometimes values, most of the time there's only one, sometimes multiple, when x is equal to 0. Obviously this one's called the y-intercept. Extreme values are points that are higher or lower than all others near them. So it's usually, this is a place where the graph changes directions. So for example, the vertex of a parabola would be an extreme value because it's higher than any other point close to it. So two definitions that go with this are it would be called a local maximum, or in plural maxima. But when you're just talking about one, it would just be called a maximum, and a local minimum. So that's just local, means just right in that one spot. So the graph might go higher than that, but in that area, the points near them, it's a maximum or a minimum. So let's just look at this graph here. So this graph has a local minimum at 15, 0 and a local maximum at 5, 2000. So you can see that when you're looking at the graph, it does go higher than that point, but at that spot, that is a local maximum, and at this spot, it's a minimum. So all the points around it are higher than this point. This is a minimum. All the points around this one are lower than that one, so that's a maximum. And then we notice you have your end behavior here. So as x approaches negative infinity, y approaches negative infinity, and as x approaches infinity, y approaches infinity. Okay? And then also the other thing that you would want to make sure that you point out are the roots. And usually I like you to list those as points. So that'd be 0, 0 here, and here 15, 0. And then in this case, the y-intercept is also the same as one of the points because it's at the origin. So that's both the y-intercept and a root. Okay? So what you need to do before class is take this polynomial, use Desmos if you want to, or any other graphing software that you prefer. Graph that polynomial, and then sketch a graph of it and describe its key features. So all the things we talked about, the local maxima and minima, the extreme values, the roots, intercepts, end behavior, and that's it. Okay? Bring that with you to class next time.